Welcome to this explainer. Today, we're diving into the absolute core of what makes programming so incredibly powerful, and that's decision-making. We're going to demystify how to make your Python code dynamic. So instead of just running the exact same rigid steps every single time, your program actually starts thinking and making choices. All right, let's jump right into it. Here's a quick look at our roadmap for today. We'll start with making decisions in Python, move on to the if and else statements, cover elif and nested logic, look at some common beginner mistakes, and finally wrap up with real-world applications. Starting right off with Section 1, making decisions in Python. To really understand how a program decides what action to perform, think about your own daily choices. Just like we make decisions every day based on different situations, well, programs do too. If it's raining outside, you decide to carry an umbrella. If it's not raining, you leave it behind. It's just a simple assessment of the situation that leads to a specific action. Python operates in exactly the same way using what we call conditional statements. Basically, a conditional statement allows your code to look at a situation, evaluate it as either true or false, and then execute a completely different block of code based on that result, true or false. That is the fundamental heartbeat of logic in Python. Moving right along to Section 2, the if and else statements. So, the simplest and honestly most essential block is the if statement. The syntax is pretty straightforward. If condition, followed by a colon, execute this statement. But beware, Python relies entirely on indentation. The code inside your if block absolutely must be indented. Forgetting to indent is kind of a rite of passage for every Python coder, and it's going to immediately trigger an indentation error. Python simply won't know which code belongs to your condition. Let's look at how an outcome actually plays out. When a condition is true, say we're checking if a user's age is greater than 18, and they input 20, the condition evaluates to true. The code inside that if block executes perfectly, triumphantly printing our output, "You are eligible to vote." But, we gotta ask, what if the condition is false? That is exactly where the else statement steps in, providing a backup action. Sometimes we want one specific action when the condition is true, and a completely different action when the condition is false. Think of it like a fork in the road. The syntax just becomes if condition, execute statement 1, else execute statement 2. Imagine you're building a school's grading system and you're calculating a pass or fail status based on a test score. If the score is above a certain mark, they pass. But if the condition is false, the else statement picks in and outputs a fail. This right here is a perfect, everyday if-else scenario. Okay, on to Section 3, elif and nested logic. What if we have way more than just two options? Well, Python provides elif, which is just short for else if. This elegantly checks a sequence of conditions strictly from top to bottom. It checks condition 1. If that's false, it moves to condition 2. If that's false, it evaluates condition 3, and so on, all the way down until it hits a default else, if literally everything else fails. Now, the really crucial point is this. Python checks from top to bottom, but as soon as it hits a true condition, like, say, a score qualifying for a grade B, it executes that block and smartly skips the rest. This makes your code incredibly fast and efficient because it doesn't waste time checking all those remaining conditions. It just finds the first match, runs the code, and moves on. Sometimes a decision requires a sub-decision. Like, if this first thing is true, okay, now let me check a second condition. This is precisely when we nest an if statement securely inside another one. The source material captures it perfectly. An if statement inside another if statement is called a nested if. They are incredibly useful when you have multiple dependent conditions that need to be verified. Think about the very last time you logged into a website. This is a classic nested if situation. The website's code checks your username first. If that's true, it opens up a nested if to verify your password. And if both are true, boom, it results in a successful login. Aside from nesting, we can securely combine multiple conditions onto a single line using logical operators. If we use the AND operator, well, both conditions must be true for the block to execute, like checking if you're of age and registered to vote. If we use the OR operator, only one of the conditions needs to be true, like checking if today is a Saturday or a Sunday to declare it a weekend. This really saves you from writing clunky, overly nested code when a single, clean line does the trick. Let's hit Section 4, common beginner mistakes, because let's be honest, we all make them. Probably the most frequent mistake beginners make is confusing the equal signs. Using a single equal sign inside a condition is a massive trap. That is used strictly for assigning values to a variable. To actually compare two values to see if they are the exact same, you must always use the double equals sign. Another classic and honestly pretty frustrating error is just simply forgetting your punctuation. If you forget to add the colon at the very end of your if, elif, or else statement, Python is going to immediately throw an error. That tiny little colon is exactly what signals to Python that an indented code block is about to start, so always double-check those colons. Finally, Section 5, Real-World Applications. Conditional statements are quite literally the invisible superpower dictating the logic of almost every software application you interact with on a daily basis. It's not just grading systems or login portals. It's ATM machines deciding if you have enough balance to withdraw cash. It's traffic signals determining when to turn red based on timing or sensors. It's the core logic of your favorite games and mobile applications. Even those popular beginner mini projects rely entirely on this fundamental logic. And, you can start small. A really great practice project is writing code that takes a user's input, like the number 8, and uses conditional statements to output whether it's an even number or an odd one. Or you could write a program to check the largest of two numbers. The whole shebang all stems from if, elif, and else. Conditional statements are undeniably one of the most absolutely crucial concepts in programming because they give your programs the ability to actually make decisions. So now that you've mastered how to bring your Python code to life with dynamic decision-making, I want to leave you with this final thought. What real-world program will you build first? Thanks so much for joining me for this explainer, and definitely keep practicing those conditional statements.